In a distant region of our solar system, approximately 880 million miles away from Earth, lies a fascinating world that has intrigued astronomers for centuries. Let's delve into the enigmatic domain of Saturn, the majestic gas giant filled with mysteries, from the intriguing hexagonal pattern at its north pole to the enigmatic phenomena observed from outer space. Recently, scientists detected something unusual about Saturn's rings, raising concerns about the future of this cosmic neighbor of ours. While we can't observe Saturn's magnificent rings from Earth, astronomers are intrigued by the impending possibility of their disappearance and the strange movements occurring within the rings. The first detailed images of Saturn were recorded by the Pioneer 11 spacecraft in 1979, marking the beginning of our journey toward understanding this colossal star. However, it was only with the arrival of the Cassini mission in 2004 that researchers could truly dive into the wonders of this ring-shelled planet. Each study conducted on Saturn reveals surprising insights, highlighting how much we still don't know about this intricate celestial giant. Saturn, the second largest planet in the solar system, hosts a core that is about half the radius of the planet itself, with a mass ranging between 12 and 20 times that of Earth. Interestingly, if there were a reservoir large enough, Saturn would float in water, due to its density of about 0.687 grams per cubic centimeter, making it the least dense of all the planets in our solar system. But that's not all. While most planets in our solar system are nearly perfect spheres, Saturn stands out as the most flattened among them. With an orbital period of about 10.5 hours, the planet's rapid rotation results in significant flattening at the poles and a bulge at the equator. At the equator, Saturn measures around 75,000 miles in diameter, while the distance between its north and south poles is approximately 68,000 miles. Saturn's iconic yellow and golden bands, visible from Earth, are generated by superfast winds in the upper atmosphere that can reach up to a staggering 1,100 miles per hour. Upon closer observation of the sixth planet from the Sun, you'll notice something extraordinary: a massive hexagonal formation about 20,000 miles in diameter. This hexagonal pattern, with its colossal proportions, initially appears to be a highly sophisticated megastructure, adding to its mystery. High-resolution images captured by the Cassini mission reveal the transition of this structure from a blue to a golden hue through a spectacular animation that showcases this phenomenon in vibrant colors for the first time. At the heart of this hexagon, located at Saturn's north pole, lies a colossal hurricane with an eye that is 50% larger than any hurricane found on Earth. Reddish vortices surround this storm, spinning in sync with the hexagonal jet stream moving counterclockwise. Inside the hexagon, the particle composition is markedly different from the outside. Small haze particles are abundant inside the hexagon, while larger ones are scarce. Outside the hexagon, the opposite occurs. One of the most intriguing features of this six-sided phenomenon is its resilience. While hurricanes on Earth last only a few weeks, Saturn's remarkable hexagon has persisted for decades, possibly even centuries. But how does such a monstrous storm form? Computer simulations have unveiled a fascinating phenomenon known as deep thermal convection. When heat is transferred through the movement of fluids or gases, it can generate atmospheric flows that give rise to large polar cyclones and an eastward-directed jet stream at high latitudes. As these atmospheric features combine in Saturn's upper layers, they form the distinctive and surprising hexagonal shape observed at the planet's north pole. The persistence of this hexagon is due to storms that originate deep within Saturn's bowels, thousands of kilometers below the cloud tops. To date, scientists have not identified any similar storm anywhere else in the universe. These hexagons are just a sample of our universe's wonders, but Saturn has intriguing features to offer. During the examination of data from the Voyager missions, scientists noticed the presence of mysterious spokes across the planet. This strange phenomenon was further explored by the Cassini mission, but surprisingly, there were no signs of these mysterious spokes, intensifying the mystery behind this unexplained phenomenon. Subsequent observations revealed that these spokes usually appear dark when viewed from above and bright when seen from below. Researchers are still unsure about the cause of these enigmatic stripes, but they know that they reappear seasonally during Saturn's spring and autumn. Like Earth, Saturn has 4 seasons, but each lasts about 7 Earth years. The hypothesis is that the mysterious spokes in Saturn's rings originate from dust particles separating from chunks of ice and floating independently from the other icy rocks. Saturn's magnetic field could be responsible for this. When the solar wind interacts with this magnetic field, it creates an electrically charged environment that influences the behavior of dust particles, causing them to temporarily group and form denser areas within the rings. Although other gas giants in our solar system also possess rings, Saturn's are the largest and most recognizable. The 7 rings were named in the order of their discovery. Located along Saturn's equator, they begin about 4,300 miles from the planet's core and extend over an impressive distance. The E-ring, for example, spans a distance of approximately 75,000 to 260,000 miles. To give a sense of scale, imagine a road running the entire length of Saturn's E-ring. If you drove at a constant speed of 100 miles per hour, it would take over 2.5 months to travel from one end to the other. Thus, while Saturn reveals many of its secrets, it also shows us that we still have much to discover about this fascinating planet and its iconic rings. Besides Saturn's well-known main rings, there is the more tenuous Phoebe ring, which extends from about 100 to 270 times the planet's radius. Much like Saturn's distinct flattened shape, its rings are incredibly thin. Detailed observations indicate that while some areas of the rings may reach a thickness of about 0.6 miles, the main rings are surprisingly slender, with only 32 feet in thickness. The particles that comprise Saturn's rings vary significantly in size, ranging from tiny icy grains, akin to dust, to substantial fragments the size of houses. There are even some exceptionally large particles that reach mountain-like dimensions. However, our understanding of the structure of Saturn's rings hasn't always been so clear. Nearly 4 centuries ago, when Galileo Galilei first pointed his telescope at Saturn, he described the gas giant as having ears or handles, which were, in fact, the elongated protrusions we now understand to be Saturn's rings. With his modest telescope, Galileo couldn't discern the intricate details of the rings, leading to his confusion with large celestial bodies positioned alongside the planet. Today, despite thinking we know almost everything about the majestic rings of the 6th planet, Saturn continues to challenge and surprise us with its many mysteries and splendors. The particles within Saturn's rings, composed almost entirely of ice water, are in a delicate balance between 2 opposing forces: Saturn's gravitational pull drawing the particles toward the planet, and the orbital velocity pushing them outward. Space scientists have long wondered whether the planet evolved jointly with its rings. The latest discoveries suggest that Saturn hasn't always had this characteristic. For more than 90% of its existence, Saturn did not possess rings. So, how and when did the rings form? One possibility is that the rings originated when small icy moons orbiting Saturn collided with each other. These collisions could have been triggered by the gravitational influence of asteroids or comets. A 2016 study proposed that the rings might be remnants of dwarf planets that collided in the distant past and now form the enigmatic rings around Saturn. Another theory suggests that a large moon collided with Titan, Saturn's largest moon. Scientists have identified a potential moon named Chrysalis, which existed before Saturn's ring formation. Computer simulations indicate that Chrysalis, similar in size to Saturn's third-largest moon, Iapetus, had its orbit destabilized due to gravitational interactions between Saturn and Neptune. This led Chrysalis to move closer to Saturn and be torn apart by the planet's gravity. Nearly 99% of Chrysalis was absorbed by the gas giant, while the remainder formed the impressive ring system we see today. Saturn, with its fascinating ring system, continues to be an object of great interest and mystery. These recent discoveries only heighten our curiosity and desire to better understand the history and evolution of this magnificent gas giant and its iconic rings. According to a recent study, Saturn's rings are between 100 and 400 million years old, but their existence may be coming to an end. A true celestial spectacle is causing Saturn's majestic rings to disappear, and in about 100 million years, they may dissipate under the influence of solar radiation or plasma clouds caused by space rock impacts. NASA estimates that every 30 minutes, the rings lose a volume of water equivalent to an Olympic-sized pool. After 4 decades of research, scientists have revealed that the circular rain over Saturn significantly impacts the planet's atmosphere, with up to 6,000 pounds of icy particles descending onto the planet every second. Besides the ring rain, Enceladus, one of Saturn's moons, shoots jets of icy water into space from its underground ocean. Some of these particles are influenced by Saturn's magnetic field and fall into the planet's atmosphere, a phenomenon known as moon rain. The ring rain of Saturn is a mixture of chemicals, including water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. In the future, this mix could alter Saturn's atmospheric balance, but it's not enough to sustain life on the planet. Recently, Saturn became the king of moons in the solar system, with 62 new satellites discovered, totaling 145 moons. Among them, Titan and Enceladus are especially intriguing to scientists because they possess essential ingredients for life. Titan has a thick atmosphere and organic molecules, including complex hydrocarbons, considered building blocks for life. Enceladus has a subterranean ocean of liquid water, making it a promising candidate to host life or support the necessary conditions for life to exist. Saturn, with its rings and numerous moons, continues to unveil mysteries that challenge and fascinate scientists and space enthusiasts. Whether through the dramatic conditions of its rings or the promising possibilities of life on its moons, Saturn remains one of the most intriguing planets in our solar system, promising many more discoveries in the future. Titan, the largest moon of Saturn, is one of the most intriguing bodies in our solar system due to its dense nitrogen-dominant atmosphere, similar to Earth's. Additionally, it has rivers, lakes, and seas, but unlike Earth, its liquid bodies are composed of methane and ethane. Methane, in particular, is associated with the metabolism of many terrestrial organisms, potentially serving as a source of energy. Although lipid membranes, crucial for life on Earth, are unlikely to withstand the harsh conditions of Titan, scientists have proposed that a substance called acrylonitrile could form stable, flexible structures similar to cellular membranes on Titan. Acrylonitrile might form exotomes, tiny hollow spheres that could serve as microscopic containers for storage and transport. Observations indicate the presence of acrylonitrile in significant amounts in Titan's atmosphere. If confirmed, this could form millions of exotomes per milliliter of liquid in the Lake Ligeia Mare, potentially surpassing the abundance of bacteria in Earth's coastal waters. NASA's Dragonfly mission, scheduled for launch in 2027, will examine Titan more deeply, bringing us closer to discovering if life can form in such a fascinating celestial body. Dragonfly, a rotorcraft drone, is designed to explore various locations on Titan, flying from point to point to study the surface composition, atmospheric chemistry, and potentially signs of biological processes. Until then, we will continue to explore candidates for extraterrestrial life within our solar system. With so many missions and discoveries underway, the search for life beyond Earth promises to offer many insights and surprises in the coming years. Stay tuned for the latest discoveries in space exploration. Ready to uncover the secrets of the universe and stay ahead on the latest scientific innovations. Subscribe to our channel now and join a curious and informed community. By subscribing, you'll be one step closer to transforming your curiosity into knowledge with content that will expand your mind and ignite new passions. Don't miss the chance to be the first to know. Click that subscribe button and start your journey today.